Yes. $23. Okay. I'm going to put one of these down. Now this is what they gave us.
Is it hazelnut?
Hazelnut, and then it is hazelnut creamer.
Yeah.
To boot. Hazelnut with hazelnut.
Oh, hazelnut coffee? That's...
Yeah, hazelnut coffee and hazelnut creamer. So, looking at this here, this is error detection, error correction. There is a problem with this problem here. So, when we look at this here, some of these, especially this one here, it might be easier to do it ourselves and then see what went wrong. Now, looking at the problem, if we wanted to factor 2x squared minus 2x minus 24, the first thing we always look for is a greatest common factor. Is there a greatest common factor between these three terms? 2. So we can take a 2 out of 2x squared and get x squared minus x minus. Do we notice an error so far? Yeah, because they put 24 instead of. So we can say something along the lines of they didn't factor the 2 out completely. They didn't factor out the 2 from 24, something along those lines. And that's really the error, is that they didn't factor the 2 out of 24. That's the error that we needed to correct. Now, if they continued from there, then the x minus 6 and x plus 4 would technically be correct because they're basing it off the 24, not based off the 12, what it should be. Now, at this point here, we've taken out the greatest common factor. So we'll have 2 sets of parentheses with 3 spaces. Now we find the sign. Since the third term is negative, our signs are opposite. One is going to be positive, one is going to be negative. Now we find the factors of the first and third term. X squared will be x and x. And the factors of 12 that we want are going to be 3 and 4. And that would be the correct answer. Because we could go through and check it and we would have gotten negative 4x plus 3x does give us negative x. And that would be the correct answer. I didn't write it up there, but we would need to have the statement that they did not factor the 2 out of 24 for the error. And then we do need the correct answer as 2 times x plus 3 times x minus 4. Actually, I take that back. They didn't factor out the second term. They only factored it out of the first. And that is a common error that I have seen in a good number of places. We'll factor the greatest common factor out of just the first term, but not all the way through. In a minute. Any other questions on the homework? Down. Yes.
Preparing gifts.
Ooh. Thank you.
You're welcome. Figured you'd want one.
Yes. All right. What we're going over today is the last part of 3.1. Today is the last section of 3.1. And what we're going to learn is something called the zero product property. I'll just go on and read the definition of this. If the product of two expressions is 0, then one or both of the expression equals 0. That makes complete sense, yes? Well, let's say it another way. we have a variable a, and I multiply it by a variable b. A could be any number, any real number. B could be any real number. Actually, a and b could be any number at all, any number we could think of. But we don't know what it is, and the only thing I will tell you is that their product, when multiplied together, is 0. What can we say about the value of A or B? Because what's the only way I can multiply two things together and get 0? If one of them's 0, yes? So according to the zero product property, it says that if I multiply any two things together and they equal 0, A is going to equal 0 or B. Mathematically, that V symbol is or. That's how we can write an or. So we're saying A is equal to 0 or B is equal to 0. Now it is possible that A and B could both be 0, and for our context, that would work as long as the value of X that's being defined as part of A and B were the same. But that's all the zero product property says, that if we have two things multiplied together to equal 0, one of them must be 0. That's all zero product property is. And it's quite helpful, because if I have a statement like this here, I have two expressions. These two here multiplied together to equal 0. It means either that the first one, k plus 1, is 0, or k minus 5 is 0. One of them has to be 0. Now we could solve the first one. K plus 1 equals 0. To get k by itself, I would subtract 1 from both sides. Telling me k is -1. K is by itself, so k is -1. Well, we can also solve for the other value of k, and we can do what? Add 5 to both sides. So, for this to be true, for this to equal 0, k has to either be -1 or 5. -1 or 5. Now, this seems odd that this would work, and there's an easy way to prove it or show it. Is I'm going to replace every k with -1. Well, our first expression, -1 plus 1 is 0. -1 minus 5 is -6. Well, 0 times -6 is 0. It works. We could check it with 5 also, because I could say 5 plus 1 times 5 minus 5. Well, our 5 plus 1 is 6. 5 minus 5 is also gives us 0. Now, we don't have to check it, but if especially on the test, if it does say check your answers, you'll need to check them. Now, you don't have to necessarily step it all the way out like we did with either one of these here, because I could type parentheses -1 plus 1, close parentheses, open parentheses, 5, -1 minus 5, close parentheses, enter in the calculator, and it should give you 0. And that's all you'd have to write. We would just have to write this. It equals 0. It checks out. We did have the correct value. And you might be thinking, well, how would I know if you actually did it or not? Well, if it was the correct answer, it would give you 0. The calculator would say it. If you had the wrong answer and you said it equals 0, it's kind of a giveaway. So, what do we think of this here so far? Not bad. 2m plus 3 times 4m plus 3 equals 0. Two things multiplied together equal 0. One of them must be 0. So we're saying that either 2m plus 3 equals 0, or 4m plus 3 is equal to 0. It doesn't matter which one we solve first because we're going to have to do them both. Minus 3 first, which will tell us that 2m is equal to negative 3. Then we would indeed divide by 2, telling me that m is equal to negative 3/2. Questions on this so far? Now we can look at the other one. First thing we can do for this one here is minus 3 from both sides, yes. And we do that, we would get 4m is equal to negative 3. Then we would indeed divide by 4. Yes, we would say that m is equal to negative 3/4. Now for both of these here, we could write these as fractions, negative 3/2, negative 3/4, or decimals. Either one works, because negative 3/2 as a decimal is negative 1.5. Negative 3/4 as a decimal is negative 0.75. They're nice decimals. We don't have a repeated decimal or something that's not as nice to try to write out. We're not having to round. We're not having to use the repeating bar above the numbers. So either one works. Questions on this here? We feel comfortable with these here, yes? All right, now we'll throw the wrench. Is this written as two things being multiplied together? When we factor, what did we end up with? We ended up with two sets of parentheses, yes? We ended up with two things being multiplied together. So all we have to do is factor, because once we factor it, we have two things multiplied together that equals 0, so one of them must be 0. So here, always look for a greatest common factor. There's not one for this here. So we'll have our two sets of parentheses with 3 spaces, and it's set equal to 0. Yes. Yes. Since the third term is positive, the signs are the same and match the sign of the middle term, so we'd have plus and plus. Then yes, our factors of x squared would be x and x. Now the factors of 21, well, there's more than one. 1 and 21, 3 and 7. 2 is not a factor. 3 is. 4 is not, because 4 times 5 is 20. It's too close to that. And that would give us 4 and 5.25. So those are pretty much right next to each other, so we are done. We can try 3 and 7 first, because there's a good chance 1 and 21 are too far apart to get us to 10. And since the signs are the same, we would be adding whatever that is together. So that means it's only going to go up, away from it. Now, we can check this. And the biggest thing I will say, especially when solving by factoring, because that's what we're doing, when you check it, do not write it underneath it. Do not write it underneath those parentheses. And that was fine with what we did yesterday or all this week, because once we said we had factored it or found the factors, we were done. We didn't have to do anything else after it. Here, we still need to solve for the value of x. So we're still going down underneath it. So when I check this, I normally check it off to the side. 7 times x is 7x. 3 times x would be plus 3x is, okay, that's the middle term we wanted, yes? Now we can continue on. Yes. Now, we do have two things multiplied together to equal 0. So one of them must be 0. So we have x plus 3 is 0. And x plus 7 is 0. So the first thing we can do is subtract 3 from both sides, telling us x is. And for the other one, we would Subtract 7 from both sides, telling us x is, and that's it. Questions on this here? Okay. X squared 10x 21. So I could plug it back in, and I'm going to do this in a calculator. So here I replaced every x in the equation with negative 7, because that was one of our answers. So we'd have negative 7 squared plus 10 times negative 7 plus 21. And what should this give us? It does indeed give us 0. So it is telling us that is the correct answer. I could do the same thing with negative 3. And we get 0. So those are the correct answers. So especially when doing the homework or solving these, if for some reason you solve it and the answers seem like something that shouldn't work or is not the correct answer, plug it back in, check it. Because if it does give you 0, then it is the correct answer. If it doesn't, then it's not. Let's look at this one here. 4x squared plus 20x minus 24. 2 does work. Yes. Yeah. Now, with this here, we always want to get the biggest one. And part of that is, if we take 4 out, we do get x squared plus 5x minus 6. Because removing 2 would work. Instead of x squared, we have 2x squared. Instead of 5x, we have 10x. Instead of 6, we have 12. Also, kind of our step I've emphasized the last few days, if there's no greatest common factor to begin with, or if there is no greatest common factor here, there can't be 1 in either parentheses. With leaving that 2, there's still a greatest common factor there, which means one of the parentheses is going to show up with the greatest common factor. It doesn't make it wrong. It is still the factors. The ACT would not consider it in simplest form because it's not all the way factored down, but it's not going to be wrong with solving. Two sets of parentheses with 3 spaces. Since the third term is negative, the signs are opposite. So we have plus and minus. Factors of x squared are x and x. Factors of 6. So 1 and 6 or 2 and 3. Which one are we going to do? I see a split. 1 and 6. Which one first? 6. And then we can check this here. X times negative 6 is negative 6x. 1 times x is plus x. And negative 6x plus x is minus 5x. Is that what we want? We got to flip the signs. So we get this here. X minus 1 times x plus 6. Well, this would give us a positive 6x minus x, which would indeed be positive 5x, because we're just flipping the signs. This xx would go from negative to positive. The x would go from positive to negative, which means our 5x goes from negative to positive. Yes? Questions on this so far? No? No questions? Now, if we look at this here, we don't have just 2 things multiplied together. We have 3, yes? There's one of those 3 that it doesn't matter. The 4. Because if we think of this in terms of the expressions, yes? Can we plug a number in to make x minus 1 be 0? Yes. Can we plug in a number to make x plus 6 be 0? Is there anything I could do purely to the 4 to make it be something other than 4? No, there's no variable, there's nothing attached to it. It's just 4, yes? So the only things I can make be 0 are inside the parentheses. Yes. Because those are the only two I can affect by plugging a number in. They're the only ones that have a variable attached with them. Yes? Yes. But for these here, most of these, we won't have any issue with it. The only time that we would care about that 4, or the number in front, is if it was 4x. We had a variable attached to it. Then we can actually change its value and do something to it. No. As the first one, we would add 1 to both sides, telling us x is equal to 1. And that's our answers there. We could plug them back in to check it, and both of them will tell us that it is equal to 0. Questions on this here?
Do you want us to give both? Or can we just put one of them?
One and -6 are both of the answers. Because with quadratics, we will always have 2 solutions. They may not be unique solutions, but we will always have 2. And what I mean by unique is that it could be that we do have a quadratic that the solution is 2 and 2. Positive 2 and positive 2. We do have 2 answers, they're just the same answer. So they're not unique. But all quadratics will have 2 answers. Questions on this here? Yes. So we're going to go on and do this one here. Now this one, on Monday, we will find how to factor it simpler, easier, and faster than what we're actually going to do here. But we're going to factor this like we've been doing already. Is there a greatest common factor between 3n squared and 75? 3. So we can factor it out. Which leaves us with n squared minus 75 divided by 3 is equal to 0. Now we've factored out all the greatest common factors. So we'll have 2 sets of parentheses equal to 0. I'm going to get a different color on one. Purple. So we have n squared, yes? For this one here, the middle term would be a number times n, yes? Do we have it? No. So realistically, it is there. It's just it's 0n. The middle term is 0. So when we find the middle term, we want it to be 0. Now, this doesn't change any of the steps. The negative 25 is still technically the third term. And when we find the signs, if the third term is positive, the signs are the same and match the sign of the middle term. And if the third term is negative, the signs are opposite. So one is positive, one is negative. Now the factors of n squared are n and n. Yes. 1 and 25 or 5 and 5. 5 and 5 is better. It is smaller. Now if we check this here, n times negative 5 is negative 5n. 5 times n is plus 5n. And it equals 0 or 0n. Yes. Questions on how we found these factors? So even though there wasn't a middle term, we could still find it. Now when we set these equal to 0, n plus 5 is equal to 0, and n minus 5. We're not concerned about the 3 because it's just what we would call a scalar. Now at this point, we can subtract 5 from both sides. And on the other one, we can add 5. You know, because for the most part, we didn't need a ton of space for each one of these. Because if we understand, especially if we feel comfortable with factoring, the product, zero product property, them combined, isn't a huge hurdle. So do we feel comfortable with these so far? In that case, I'm going to jump ahead. Because if we feel comfortable with these, I want to move on ahead.
Yeah.
Zero product property.
No longer 0.
It's no longer 0, yes? But can we make it be 0?
Yeah.
How can we move the negative 9p over? Yeah. Because I can add 9p to both sides. Because on the left-hand side, we'll still have 3p squared. 9p is not a like term to any of them, so we still have plus 9p. Minus 120 is equal to 0. Area. If you want to set up a fence that encompasses 120 square feet, but you want the width to be twice the length, because we could set it up as, so the length or width is equal to twice the length, going the other way. So we have a square, we have the length, and the width is going to be twice that amount, and we'll say that its total area is 120. Well, let's say one more than twice the length. So what we're saying is the length times 2 times the length plus 1 is equal to, we would multiply, get it into a quadratic, and solve. So quadratics do have uses there. Falling bodies is the general classification. It's any object that is thrown up or comes down. So rockets, passes with footballs. I mean, if we keep it in the most generalist sense, we don't, well, we can technically include gravity, but when I say most general sense, we're not going to include wind resistance, or wind, crosswind, any type of wind resistance, any friction, how the spiral would affect the throw. In a perfect atmosphere and the ground is completely level, we can predict or project most things. Higher than that, it still works, but you have to throw in a lot more calculations. Let's look at this here. What would be the next step? We can factor out a 3. P squared plus 3p minus 40 is equal to 0. And then we can go from there, but let's do signs first. The third term is negative, so the signs are opposite. Factors of the first and third term. Factors of p squared are p and p. Now, factors of 40, yes, there are a good number of factors for 40. Because we have 1 and 40, 2 and 20. Is 3 a factor? 3 is not. 5 and 8. Yeah. 2 and 20 are a bit far apart. Yes, as long as the numbers in front of P or the variable are both 1. Because when we check it, because P times negative 5 would be negative 5P. 8 times P would be plus 8P, giving us 3P. Now, if the P values had been, say, 2, we'd have, but then the process of what you all were also doing, not so much subtracting, but seeing that the middle number, the middle term is smaller, so we're probably looking at factors that are closer together. So even if we had values of P, and again, it's not a guarantee that it will automatically give us what we want, but it gives us a better starting spot. That I know small middle term, even if we did have factors for the number in front of P, there's a good chance 1 in 40 is probably not going to be it unless P gives us some pretty interesting values. So that's kind of a way to simplify things down. And when I was talking about the other day, the more that we do these, the better we'll see them. And that's part of it, noticing these little trends and how it works. Now, the last thing we need to do is set P plus 8 and P minus 5 equal to 0. So we would subtract 8 from both sides, telling us P is negative 8. And we would add 5 to both sides, telling us P is equal to 5. And again, I think y'all were the ones that asked me yesterday if I was able to see some of these. But part of that, like we were just looking at this here, is how I see most of them. And I start seeing how they work together, numbers multiply, add, subtract, and we can start trying them in our head once we get comfortable with it. Yeah. Now, factoring is one of the ways that we have for solving. There's going to be about 5, and factoring is one of the ways to solve quadratics.
But it's the hardest. Like, they're not the hardest.
It works as long as the factors are nice numbers. As in, we don't have radicals. The answers or the solutions for a quadratic are not radicals, so square root of 2, square root of 3 as our answer. We don't have ugly decimals, which would come from radicals, and we have nice numbers. Then it works nicer. Fractional answers, rational answers will work well with factoring. That means we could factor it and we will get to a rational answer. If we get to irrational answers, then factoring doesn't work well. If we get to imaginary or complex solutions, which we will cover, y'all haven't covered that yet, factoring doesn't work. Well, it technically does, but you really need to know the solution to be able to factor it. So you have to know the answer to factor it. So, but when we get those, we have another method that works for it. Questions on this here? And I'm going to go on and give you all the assignment because the rest of these here are the same exact thing. Because even if the problem is not set equal to 0, we just need to make it be 0. I've been through 23 odd. Four. 9:45. Pass them, Collier. Oh, and you're going to put that one on Owen's desk. Oh, and we're going that way. So give him the grace. But if you do have questions on these, please ask. Because the first two are already in factored form. 3 and 4, 5 are already kind of set up. And the last ones are just getting it equal to 0. So you can get it equal to 0 either way. So you can move everything from the right to the left or left to the right and factor from there.